Assalamualaikum, my name is AMIRUL HAKIM bin KHAIRRUL WAZLI. My ID number is FA21007. Our topic for this project is sound source for drilling machine. Okay, I will begin with introduction. Microphone as sensors. Okay, passive transducers directly convert acoustic energy into electrical energy without needing extra power. Active transducers use sound wave to convert external electrical energy in real time. Microphones are designed based on their intent, purpose, and react differently based on the size relative to the sound wavelength. Displacement control transducers generate voltage proportional to the diaphragm displacement, and velocity transducers form the basis of operation for magnetic microphones using the law of induction. Okay, for principle of application, microphones transform sound wave into electrical signals, which are then amplified and played through speakers or headphones. The signal should remain mostly intact from microphone to speaker. Microphones produce self-noise due to internal components like transformers and circuit resistance. Measured using the signal-to-noise ratio, which compares signal strength to background noise. Okay, for industry of application. Microphones are widely used in communication, entertainment, and technology industries. Different types of microphones are used depending on the application. For example, performers use microphones on stage to amplify their voice for a larger audience. In mobile phones, microphones enable long-distance communication by converting voice into electric signals. Microphones can also measure sound pressure with pressure field microphones designed for this purpose. Okay, for generalized model of an instrumentation system, this is the flow diagram sensor system. Okay, firstly is analog input. Analog input is up to 32 input modules, 512 channels, to output modules, 32 channels. For digital meter, a digital meter displays values and offers various customization options for its display windows. Values can be shown in binary, octal, decimal, or time formats, with options for displaying minimum, maximum, average, or single numbers. Users can customize the instrument's range, pointers, colors, trend indications, and digital count to match the data being measured. Next is formula interpreter. It is to connect data from many channels using formula that represent mathematical functions. Next is write data to these files, either floppy or hard, that support the ZLAC format. Then, YT chart. It is high-speed scope display for fast data with a wide range of display options. Then, data window. Data window is several kinds of assessment windows, including Bartlett, Gauss, and others. Lastly is FFT, to compute and examine a signal's discrete spectrum. Okay, for microphone sensor system. A microphone converts sound wave into electrical signals categorized by the type of electrical transducer used. The microphone response can be affected by its design and the size and shape of its components. Amplifiers have electrical and acoustic aspects with impedance affecting their output. High impedance amplifiers provide clearer and deeper sounds, while directionality determines how well an amplifier picks up sound from different angles. Different types of transducers include moving coil, moving iron, and carbon receivers.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ILHAM bin SHAMSUDDIN and my ID number is FA21014. So for me, today I would like to present about the literature review. So in the literature review part, there are two things that I want to highlight. Firstly is acoustic measurement, and then the vibration measurement. Firstly, we must know about the parameters of vibration, measurement and instrumentation techniques, instruments, application and importance. What is important in our project? For methodology, for our project, we'll be using a Handrill to generate sound using the DaisyLab software that we installed on our computer. We will build a virtual instrumentation system that will allow us to collect time and frequency domain data for analysis. So basically, this is our material and equipment. So first material or equipment is Handrill, which is Handrill functioning to the sound as the sound source for the acoustic measurement. And then we have a laptop. We use a laptop to install DaisyLab, the program we use to create our virtual instrumentation. And then we must have the microphone, which is our transducer for recording the sound produced by our Handrill was a wireless microphone with an integrated microphone. And then we need to download the DaisyLab, because we use DaisyLab to create a virtual instrumentation system that collect time and frequency domain data for analysis. And then finally, we will utilize the sound meter apps Decibel X in our project to measure the sound pressure or SPM, which will be used to determine the VREF value. So basically, this is our experimental setup. We have a laptop, we have a app sound, Handrill, and recorder. So basically, this is our DaisyLab layout from the beginning until the ending, which is there is 8 steps we need to do in this DaisyLab software. For sound pressure level measuring setup, firstly we need to place the microphone wireless of the phone, which is the place we used to install the app near the source of sound. And then we set up the apparatus, and then we start the measurement of SPL along with the DaisyLab to have the accurate measurement between the app and the DaisyLab software. And finally, to get the VREF, use the sound pressure level equation, which is SPL equal to 20 log V over VREF. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Shafiz AZMIL. My material number is MA21080. So I will present about the result. So first we need to calculation of the VREF. So first we need to determine the VREF using the SPL and VRMS. So we need to calculate the reference voltage by inputting the sound pressure level and the value obtained from the Decibel X smartphone app, and then the VRMS value from the first digital meter in the DaisyLab module setup. So we can accurate sound recording for SPL reading and record the Handrill sound using the microphone from the headphone or earbud to ensure accurate result, and use the mean value of the decibel reading for the SPL measurement. So next we need to record the value for that required from the first digital meter. So after we obtain from the first digital meter, we can calculate the VREF. So we get the VREF is 0.00002954. So the VREF is then put into the equation and formulated in the printer, and we click start at the switch. As a result, we gain the value of the dB, time domain and frequency domain as shown below. So as we can see, we can get the VRMS value, dB value, and the graph for the frequency domain and the time domain.
Hello, Assalamualaikum. My name is Muhammad NAJMI bin NAZRI and my metric number is MA21082. Today I will represent about discussion of our project. First is about the frequency of the analysis. First major peak observed at 6500 Hz with a secondary peak around 4500 Hz. Numerous spikes in data indicate significant disturbance, likely from background noises like air conditioner. Second is a possible causes of interference, background noises, and wear and tear on the Handrill may contribute to inconsistent frequency emissions. Thirdly is about sound level measurement. Use DAISY software and Decibel X apps. Reading DAISY reported 95.20 dB, Decibel X average 95.2 dB. Tolerance between measurement is 0 dB, suggesting minimal discrepancy. Prefer DAISY for accuracy. Smartphone setting can distort its signals. Measurement setup: sampling frequency set to 10,000 Hz with a block size of 20,000 samples, equivalent to 2 seconds per block. Data sent every 2 seconds to minimize noise. Apply data windowing before FFT processing to reduce leakage and improve signal accuracy. Lastly, the recommendation: use the noise reduction settings on wireless microphones to further minimize interference during measurements.